So, in our class today, we are going to consider the hyperbola. It is an important function as it is part of our syllabus. Therefore, it has to be important. As we have the basics of this hyperbola, just gonna explain the basics of what we actually had before so that we can understand each other. In this function, we are going to notice that it was given in the form of y is equal to a over x, or it can be given as the product of these two. X, y is equal to a, on a condition that a can never be equal to 0, x cannot be equal to 0, y also cannot be equal to 0. Any function of that, it's a hyperbola 2 over x. You are given the product of xy is equal to minus 2. Xy is equal to 5. That's a hyperbola, which is limited when it is of this nature. It is limited in these quadrants. It is limited in these quadrants. Only it cannot cross the x-axis or the y-axis. Guys, I'm still here when it is like this. It cannot cross the x-axis like this. It is limited in within the axis like this, in the first and the other one in the third, depending with the value of a that we are given. For a which is greater than 0, as we saw that a cannot be equal to 0, to just talk of a being greater than 0, meaning to say we're talking of what? Positive values. Our function is going to be like this in the first quadrant and another one in the second quadrant. This is how your function will look like. For a hyperbola, you just have to sketch in that manner. Where it is limited now to the condition that the x-axis, as we can see, it cannot cross that x-axis. So the x-axis becomes becomes the asymptote. And also the y-axis become the asymptote. Remember the asymptote where our graph cannot pass. The limiting values. Y is equal to 0 and x is equal to 0. That will be your asymptotes. In that case, equation of x is equal to 0 and y is equal to 0. X is equal to 0 being what? The vertical. And y is equal to 0 being what? For the horizontal. This same line that we are seeing, it is for the domain and also for the range. It is not limited. It is for any x value that we are going to have, as long x cannot be equal to 0. X cannot be equal to 0. So meaning to say, when you are working with a hyperbola, that is a condition that you must consider. X is not supposed to be equal to what? X is not supposed to be equal to 0. So this part also affects the y condition. As we have, because of these asymptotes, y cannot be equal to 0 again. So it is very, very important to note or to notice these conditions when you're answering your questions. Attempting these questions, it is important. X cannot be equal to 0, y cannot be equal to 0. Okay? Also on this function, it is being divided into two equal parts by the axis of symmetry. And as we know, this line, which has a positive gradient, which divides even our Cartesian plane into two equal parts. That's the line of y is equal to x. The one with the negative gradient, y is equal to minus x. That is what is referring the axis of symmetry, dividing the graph into two equal parts. So our function is going to be opposed. This function is going to be opposed when our a is less than 0, when we talk of the negative values, just like what we had on our Cartesian plan, but this time the graph is going to be determined or is going to be obtained in this quadrant, the second and the fourth quadrant, like this. That is the condition this time. Where x cannot be equal to 0, y cannot be equal to 0. So those are the asymptotes, just like what we had before. And the axis of symmetry, which divides our graph into two equal parts, will be the line of y is equal to minus x. That will be the axis of symmetry, the one with the negative gradient. So this hyperbola of this function, of this knot, yes, they can just, guys, give you the basics, maybe under exam condition. Like, guys, exam you should be just given those basics part into like being extended. So the basic part, yes, just know it, but we need to extend this into this form where there is a shift that can happen in these functions. We can have a shift in the end. When you are given this format, which can differ with your textbook, you can have other textbooks writing this as y is equal to a over x minus p like this, plus q. When given it in this format, it has changed, guys. So it follows that for this format that we are having, we can determine the asymptotes. All right? The vertical asymptote for x, it will be equal to p. You take that x minus p. Remember, x always, I said, you equate to 0. So x will be equal to what? P. So meaning to say, for the asymptotes, this time we are going to have x being equal to p and y being equal to q. So for the y, you just take it as it is. Y is equal to q. So the x, which is equal to p, that is our vertical asymptote. Remember, that's a vertical line. Vertical asymptote. All right? Remember, vertical lines are like this. X is equal to this. And this will be the horizontal. That will be our horizontal asymptote. For the values of y is equal to p. The intercepts, all right, can be determined. X-intercept, y-intercept, we know that x must be equal to 0, y must be equal to those conditions. Where for the asymptote, just like what we had here, when I was talking about the issue of the range, remember I was saying, let me write, x cannot be equal to 0. But x will be what? An element of all the real numbers. But in that condition, it cannot be equal to 0. So guys, when I'm talking of x in terms of range, this is our domain. All right, I think someone is just tired. Been recording a lot of videos. Anyways, let's see. Then we talk of the range. So as for the range, y is an element of the real numbers again, but y cannot be equal to 0. This is for both of these two. But for the both functions, sorry. But for this one, the asymptotes, because they affect the domain and the range, you are going to notice that this time our domain will be represented as, all right, so as for the domain, it will be limited that our x is going to be all the real terms, real numbers, but cannot be equal to what? To p. The x, which is equal to p, is an asymptote. So x cannot be equal to that value of p. For the range, talking of the y values in our range, we are going to have a condition of y being also an element of the real numbers, but y cannot be equal to the value which is on the asymptote. So y cannot be equal to q. That is the condition. So we are going to refer typical questions about this, like understanding, drawing of the functions, and later on, also referring to the axis of symmetry, just for the sake of revision. All right, I'm going to add about the axis of symmetry. All right, let me just also write it here. The axis of symmetry, then I'll explain later on. As for the axis of symmetry, this time we are not going to have directly our function like this and in this way where it is going to be y is equal to x. We are going to have our function maybe because of the shift that has happened, the transformation of the original function that we had before. Maybe we are going to have our function like this. All right. And another part maybe somewhere there. And the line maybe it's like this. Or the line maybe it's like this. Or the line maybe it's like, we do not know how the line it is going to be given as. All right. But in any condition that you are going to have on the axis of symmetry on those lines, they are going to be given or they are going to be determined in one way or in one format. For the lines that has got positive gradients, as long the axis of symmetry is a line like this, which has got a positive gradient, we are going to have our equation in the form of y is equal to x plus k1. All right, so it can be plus, or here it can be a minus depending with what you are given. Some they can use the letter q, you can use the letter k or whatever that you want. So I'm just gonna write k1. If the line has got a negative gradient like this, in that case, y is equal to minus x plus k2. This will be the format. Take note, I'm not writing, guys, y is equal to mx plus k1 like this, where m is going to change to be a certain number. Maybe m is equal to 2, maybe m is equal to minus 3. I'm not writing that way. I'm writing y is equal to x, meaning to say already the gradient is there. I'm writing y is equal to minus x. It means already the gradient is there. The gradient here is minus 1. The gradient there is 1. You do not calculate any gradient there. You do not calculate the gradient. The format is the value that you need to calculate is this one, the k. So you can write maybe it's c, whatever that you understand there. It is the only value that you need to calculate. Here, there's nothing that you do. Already, this one, the gradient is going to be 1 when it is of a positive. For a negative, it will be having a gradient of -1. That one is not going to change here. You are not going to have a -2 or a -3 in future. No, it will be remain as a -1. So worry about these ones. So how are you going to find the value for k or the constant? Because y and this one is not going to change. To find k, you are going to use the coordinate, which is the point of intersection of the asymptotes. You use the point of intersection of the asymptotes PQ. So this axis of symmetry happens, or it passes through the axis of symmetry. So let us just note it passes through the intersection. All right, so it's going to pass through the intersection with the axis of symmetry. With the asymptote. So this one, the intersection, it passes through the intersection of the intersection of the asymptotes. All right, that is of the asymptotes. So that is at what? That is at point. That is, all right. So I'm just gonna write in short. That is at point what? At point PQ. At point PQ. If the point PQ represents the intersection of the asymptotes, remember these are two equations. X is equal to P, maybe it's like this. Y is equal to Q, it's like this. They meet at a certain point. So maybe the point is 2, 3. That is the one that we are referring to at the axis. At the asymptotes, the intersection of those asymptotes. So if this or the axis of symmetry passes through this point, it means we can use it to we can substitute it to find K1 and K2. So simply substitute this to find what? K1 and K2. So that's to find substitute. So you substitute the point PQ to find, all right, that is to find the values of K1 and K2, to find the values of K1 and K2. So that K1 and K2 depends with what you're given. Your teacher can give you as Q, they can give you as C, they can give you any letter. It can be any letter there. But take note, here there is nothing that you do. It remains like this for every function that you are going to have in your syllabus. So do not worry about that one. So you just substitute the point PQ to find what K1 and K2, just like that. So like I said, this one is going to be something else that we are going to refer in the future, working with questions. But for now, let us just take the notes, all right? Then also with this information that we had, guys, this is the one that we are given here in short, all right? The dotted lines are the asymptotes, as we have maybe our graphs being drawn in whatever manner that you be given, where for the domain, we are going to have the x values being the real terms, but x cannot be equal to minus p. When they refer it like this, it means you'll be having your x's as x, the asymptote as x is equal to minus p, y is equal to q. When you are given the formula with a positive here, it changes to a negative. When you are given the formula with a negative, it changes to a positive. So guys, be careful there. All right, there they are referring to their own function here because they had a positive. So for the asymptote, we are going to have the asymptote at x is equal to minus p. That is why we are using that minus p. X cannot be equal to minus p. The range y cannot be equal to q. All right, so that is it, guys. I explained about this. This is the same way that I was saying. For the lines of symmetry, we are going to use this one. So as you can see here, they are using y is equal to x plus c and y is equal to minus x plus c. So it depends with your understanding. You can use k, you can use c, any letter of your choice. All right. So guys, that one, do not worry about that. So questions can be on how to sketch or how to draw now, sketching this hyperbola in this format or in the form of y is equal to a into x over x minus p plus q. Like I explained, it can be like this depending with your textbook. One, you are going to need the asymptotes. Determine the asymptotes. Remember, x is equal to p, y is equal to q. Here, x is equal to minus p, y is equal to q. All right? With those asymptotes, before you draw the asymptotes on the set of axes, okay, this one we are going to look into it later on. But from there, what you need is to determine the x-intercept. All right? Remember, your x-intercept does not change. Y is always equal to 0. Also, for the y-intercept, x must be equal to 0. Then you use this idea of drawing the asymptotes, this and that, so that we can plot or draw or sketch our graph at the end using what? Freehand. So we are going to see this. As you can see, guys, it's a direct. This is direct, just direct. Just a direct approach that we are having there. As long you understand these basics, guys, you're not going to have a challenge in attempting questions. So let us quickly see how questions can be given as we have this question. I'm just going to hope it to be clear. So this is it. We are given to consider this function. F of x is equal to 2 over, all right? So that is our f of x. Okay, let's see what we are given there. So we are told that f of x is equal to 2 over x minus 3 plus 1. So remember that the a there represents the shape. This part is not going to change. We talked about this a here on top. A is always on the shape. That is, if a is greater than 0, the shape is going to be in this manner. All right. Okay, guys, this is just a vice versa of what is happening in that case. If we are given these typical functions, guys, where a is greater than 0, this is the condition, this one. Here, I don't know if you are using, it's supposed to be, I just took this part of the picture. It's supposed to be, yeah, it's supposed to be mind the gap or something. So if you're using that for your revisions, guys, just make sure you correct this part, all right? Just make sure you correct this part. I want us to have it this way. There are two graphs. This one is for A, which is greater than 0, which is in the first quadrant and third quadrant. It's for A, which is greater than 0. So please correct this one. All right. So you see your textbooks, guys, sometimes they do not revise. They revise, but they do not check properly on revising. So let's just correct. So this is for A, which is less than 0. So this is for the shape, right? We are going to notice that one when we are sketching this graph that we are seeing. So this is what we have. F of x is equal to 2 over x minus 1. And from there, we are given 2 over x minus 3 plus 1. So noticing that our a is positive 2 from what we are given there, you can see that our a is positive 2. So it is going to affect the shape. A is greater than 0. We are going to notice that whatever asymptote that you'll be having something of this nature, another one there, another one there, like that is the condition of A is greater than something like this, okay? So this is what we are going to notice at the end. So we'll see that one. We'll see that one. Let's answer the questions. Write down the equation of this, calculate this, this and that. All this is preparing us to the last question, which is to sketch. But if there's anything that you haven't calculated, which is needed here, then you have to calculate it. But all this, you see that it is just a preparation for you to find that. Okay, so let's find A. Write down the equations of the asymptotes of F. All right, remember I said we're going to take the x minus 3. This one we equate to 0. X minus 3 must be equal to 0. So x is equal to 3, which is our vertical asymptote. Then for the y values, we just take this one as it is. Y is equal to 1 as it is like that. All right, that is for the first part. Moving on to the second part, we have got calculate the coordinates of the x and y intercepts of f. All right, so that's let's start with the y-intercept. That one is just going to be easier. For the y-intercept, we know that x must be equal to 0. So just substitute in place of x, y is equal to 2 over x. That's a 0 there. So that's 0 minus 3 plus 1. On your calculator, use your calculator direct as it is. This is going to give you the exact value. All right, so let us just have our calculator. That's 2 over what? That's 0 minus 3. Then move this one aside, add a 1 like this. That was going to give us 1 over 3. So this is the y value, which is the y-intercept. All right. We've got the y-intercept. Then we also need the x-intercept or the x-intercept, depending with what you're going to have. All right. So that's for the x-intercept. Y is equal to what? Y is equal to 0. So in place of y, which is our f of x there, all right, this one, or f of x, we are going to put a 0, means that this one is equal to 0. So we are going to have it as an equation 2 over what? X minus 3, like this, plus 1 is equal to 0. Remember, you formed an equation where you need to solve for what? Where you need to solve for x. So how are you going to solve for x? Take the negative 1 to the other side, it becomes a negative 1. So that's 2 over x minus 3 is equal to minus 1. Remember, this is a whole number. There we have got a fraction. So put it to be a fraction, write it as over 1 like this, so that it becomes what? A fraction. So by cross multiplying, this was going to multiply this side. This was going to multiply this side. So take note, guys, x minus 3 is affected by minus 1. Everything there, here, everything here is affected by what? Minus 1. So it's minus 1 times x. Minus 1 times x, which is minus x. Minus 1 times minus 3, which is positive 3. Minus 1 times x. Minus 1 times minus 3. Then 1 times 2, which is what? Which is 2. So you can solve for x, guys, depending on this one, guys, solve the way that you understand. I'm going to take the 3 to the other side so that it's going to be negative 3. That's 2 minus 3, which is minus 1. Divide by the negative. So x was going to be positive 1 if we are to divide by the negative. So that's the condition. Meaning to say the y-intercept, as we have as a point, x is equal to 0. Y is what? 1 over 3. As for the x-intercept, what is it that we have? X is 1. A point, you start with x. What about the value of y? The value of y is the one that we had, which is what? Which is 0. So that was the condition there. All right. So we have got these ones. All right. These ones, we have them. All right. Then write down the domain and range. Remember, the domain and range is limited here from the x and the y values. All right. So I'm just going to have our part C here. Remember, I said for the domain referring to the x values, x must be an element of all the real terms, but limited here that x cannot be equal to 3. All right. So x cannot be equal to 3. All right, then we move on to the range referring to the y values, also an element of the real terms, but these y values cannot be equal to what? It cannot be equal to 1. Y can never be equal to 1 because that's a asymptote that you are given there. All right, so this one is direct. Then we are now given to sketch the graph of f of x, clearly showing all. What is that you're supposed to show? All asymptotes and intercepts with the axis. So we need the asymptotes and also the intercepts. All right. So as you can see, the asymptotes are already there, 3 and 1. The axis or the intercepts are already there. So this is what we are going to need. Remember there we said a, as we can see from these numbers, we said a is greater than 0. So the shape is going to be like this. So that is, okay, let us just have our sketch. Just going to call this one D. So this is just a sketch, guys. I hope you understand me here. Gonna have, just gonna have something like this. So this is our x-axis, our y-axis, that's 0 there. All right, let's just say, okay, these numbers, okay, 3, something like that, approximately to up to 4, or just like that. Let's just say I've got 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 1, minus 2, minus 3,
minus 4. I do not like writing these numbers like it because at the end, remember, this is not exact unless you are given the Cartesian plan. Like in most cases, you are not given. So just mark the points, guys. Do not worry about these numbers. All right. So what is that we need? First, we are going to you start with these ones, the asymptotes. You start with the asymptotes. For the asymptotes, remember, our graph cannot pass these values. X is equal to 3 and y is equal to 1. X is equal to 3. Where is x is equal to 3? Here, a vertical line. It cannot pass this one. So you can have it as a broken line. It's up to you at x is equal to 3. That's an asymptote. Our graph cannot pass here. And y is equal to 1, where y is, that is where we are going to have our line. Y is equal to 1. You can have a continuous line, it's fine, but for asymptotes, it's best that you just use what? Broken lines like that. So that's for y is equal to 1. So our graph is limited in within these asymptotes, just as it was supposed to be when it was y is equal to a over x, and this a is a positive. It was limited between the x-axis and the y-axis like this. But this time, it is not limited by the x-axis. No, it is limited by the asymptotes. So we are going to have our function in within these asymptotes here, and another one in within this side. We do not know how it is going to, but it will be this side. Just like what we have first and third quadrant. Same approach, but this time limited with what? The asymptotes. So that is the purpose of these asymptotes. All right? That is the purpose there. The purpose is there. That is the purpose. Is when we have the asymptotes, just like when we have the x and the y axis, it will be here. Another one will be this side. So how are we going to have a function this side where we do not, guys? Can we mark a point here? There is no point here at all. Because of what? Because of these asymptotes. There is no point unless if we are to have our point on our own. All right. Unless we are to have that, because we do not have that point in that interval. So we can just have a point which is what? Above these 3. All right? Above 3, we can use a 4. Because x cannot be equal to 3. So you can just choose a point of your choice so that you just mark 1 point there. You can just say when x is equal to 4, substitute a 4 here. That was going to be 2 over 2, which is 1. 1 plus 1, which is 2. So that will be, okay, that was going to be 2 over 1, guys, which is 2 plus 1, which is 3. Guys, just use your calculator there. Why am I using my head here? Just use the calculator. So when x is 3, when x is 4, y is equal to 3. This one. When x is 4, y is 3. It's just a point that you can just use. It's not even part of your graph. You can use any point when x is 5, when x is 6, whatever that you want, just to indicate on this side, because we are limited because of the points. There is no point which can lie. There is no intercept. It cannot intersect with the y-axis. Look where the y-axis is. Look where the x-axis is. The graph cannot pass here. It cannot pass these asymptotes. So you can just indicate any point like 4. We said it's what? 4, 3. So we calculated that one. We said it's 4, 3. So you can just mark a point 4, 3. You can use 5, you can use 6, you can use 7, any of your choice. 7, you substitute. 8, you substitute. Then you just mark that point. Let's check the other side. The other side, we can see that here we can have a shape, but it will be limited to the what? X-intercept and the y-intercept, meaning to say those x-intercept and y-intercept now, they are going to play a role, okay? What was our x-intercept, all right? Let's check from our graph. Our x-intercept here, that was 1, 0, meaning to say it passes on the x-axis at 1, this one. That's our x-intercept. The y-intercept, that's 0, a third. A third, it's 0,3333 like that. A number which is less than 1. So you can just approximate maybe somewhere here above the x-axis because It's a positive. So it's above the x-axis. So these are the intercepts, these ones. X and the y-intercept. X-intercept, the y-intercept. But as we know, guys, the shape is supposed to be like this. So we are supposed to draw our graph. Remember, it cannot pass this line. It cannot cross this line. So it is going to be below the axis, below the asymptote, all right? To the what? To the y-intercept there at a third. To the x-intercept at 1. As you are drawing this side, your graph cannot pass this line. It cannot pass this line. So it will be just as if it is to approximate that line like this, but it cannot pass this asymptote. That is the condition. So this is where we have 1. This is where we have a third. Remember, the value of y there was a third. Y is equal to 1/3, a third, 0.33 like that. So that was going to be the shape. There with the x-intercept and the y-intercept, it's enough. There is no need for us to mark another point to say we are going to have another point. Yes, if you want, you can substitute, but these points are enough. X-intercept, the y-intercept, and this other point that you are having on this other side. So that's how these questions can be given as. So as an individual, you need to work out as many questions, understanding your hyperbola. It is important because they are going to mix this hyperbola maybe with a straight line. They're going to make a lot, guys. They can even ask you to calculate the equation for the axis of symmetry. Remember, if it is like that, it is going to pass through the what? Axis, this one, the point of intersection of their asymptotes like that. It has a positive gradient. So if it was a condition like that, because we talked about this, all right, here we are done. I'm just finalizing. Yeah, remember I talked about this. Finding of this, the axis of symmetry. Lines, there are just two conditions. Which condition do we have in this case? Let's say we want to determine the axis of symmetry. This one is just on its own. Axis of symmetry. Let us just add another question. Let us say the question was for us to calculate the equation. The line has a positive gradient because it is supposed to divide this graph into 2 equal parts. But passing through the intersection of the what? Asymptotes where x is 3 and y is 1. This one is a point, this one, where these ones pass 3, 1. So it passes like this, just something like this. We are going to have a line like this. This line, it has a positive gradient. So its equation is going to be given as y is equal to x plus c. Or you can write x plus k1, whatever that you want, where this c is a value to be calculated. The only part that changes, if the line was in another way having a negative gradient, you take that one. So they can ask you the one with a positive gradient. They can ask you the one with a negative gradient. If they ask you the one with a negative gradient, you are going to take this one. That is the one with a negative gradient. But they are going to be 2. Another one with a negative gradient. So for the axis of symmetry, one will be having positive gradient, another one negative. So this is another one. Y is equal to minus x plus c. Or you can use that one where you said K1, this will be K2, depending, guys, with your understanding. But these are values to be calculated, the C. From where? Where are we going to calculate these values from? Because these axes of symmetry, they pass through the point of intersection of the asymptotes at 3, 1. We can use that point using the point 3, 1. You have the x value, you have the y value. All right, so let's start with this one, which has a positive gradient. When x is equal to 3, y is 1. All right, so y is 1 when x is equal to 3. That's 3 plus c. Take the 3 to the other side, it will be a negative. So that's 1 minus 3, which is minus 2, is equal to c. So therefore, y is equal to x plus c. That's x minus 2. This is the one that we are going to have for the one with the positive gradient. The one that has got what? A positive gradient. They can ask you the one that has got a positive gradient. They can ask you about the one which has got a negative gradient. So for the one with a negative gradient, we said our equation is going to be like this. So we need the value of c again, just like the previous case. When y is 1, x is what? 3. So that's minus 3 plus c. So we can take this to the other side, becomes a positive. That's 1 plus 3, which is 4. So 4 is equal to c. So therefore, our equation now was going to be given as y is equal to what? Minus x plus 4 for the one that has got a negative gradient. So it depends on the question, the way they ask. Determine the equation for the axis of symmetry for the line with what? A positive gradient. For the line with what? A negative gradient. You answer according to the question that you're given. And also, guys, depends the way that you have been taught. But that is how you answer these typical questions. So that was just an extra question to consider. But for our questions, this is how you're supposed to have attempted. Do not put those axis of symmetry. It was just something that we are answering on a separate question. So I want us to revise as many questions as we can. Then we are going to have question papers. Again, we are going to have another question so that we can see on a separate class. Then we can do revisions thereafter.